back to the battle at Midvale Steel.
I hunted up some especially intelligent laborers who were competent men, and I deliberately taught these men how to run a lathe and how to work right and fast, and every solitary man, when I had taught them their trade, one after another turned right around and joined the rest of the fellows and refused to work one bit faster.
Taylor decided to take the next step. He said to the men,
"Now I'm going to cut your rate in two tomorrow, and you are going to work for half price from now on. But all you have to do is turn out a fair day's work, and you can work better wages."
Eventually, the men caved in, and production rose at the Midvale Steel factory.
After that, we were good friends, but it took 3 years of hard fighting to bring this about.
Emboldened by this success, Taylor became a highly sought-after and successful management consultant. Over the years, he perfected this system of scientific management. Here's how the system worked.
First, Taylor would observe the labor process as it existed. He cataloged all the motions of the workers and timed them. He then set about, through trial and error, devising the most efficient flow of motions possible.
There are many different ways in common use for doing the same thing. There is always one method and one implement which is better than any of the rest. And this one best method and best implement can only be discovered or developed through a scientific study and analysis of all the methods and implements in use, together with accurate, minute, motion, and time study.
No job was too simple or too complex. Taylor famously spent 26 years discovering the best way to cut metal. But simple work could be rationalized as well.
In a famous example, Taylor sought to come up with a more efficient method for loading pig iron into a train car. Men had to pick up a piece of pig iron, walk up a plank, and drop the pig iron into a train car. On average, a worker could load about 12.5 tons of pig iron a day. After careful study, Taylor discovered that 47 tons a day was a proper day's work. He did this by analyzing the tiring effect of physical labor on muscle. He discovered that a man's muscles require a certain percentage of rest for an amount of work exerted. The trick was to time the ratio of work to rest for each worker so that they could work the hardest without tiring. The second step was to pick the right worker. Any old worker wouldn't do. In fact, only about 1 in 8 men could load 47 tons of pig iron a day.
With the very best of intentions, the other 7 out of 8 men were physically unable to work at this pace. Now the 1 man in 8 who was able to do this work was in no sense superior to the other men who were working on the gang. He merely happened to be a man of the type of the ox, no rare specimen of humanity, difficult to find and therefore very highly prized. On the contrary, he was a man so stupid that he was unfitted to do most kinds of laboring work even.
Taylor started with just 1 man, a large Pennsylvania Dutchman named Schmidt. These were his instructions to Schmidt.
"You will do exactly as this man tells you tomorrow, from morning till night. When he tells you to pick up a pig and walk, you pick it up and you walk. And when he tells you to sit down and rest, you sit down. You do that right straight through the day. And what's more, no back talk. Now a high-priced man does just what he's told to do, and no back talk. Do you understand that? When this man tells you to walk, you walk. And when he tells you to sit down, you sit down, and you don't talk back at him."
Taylor's next comments tell us more about this scientific selection of workmen.
This seems to be rather rough talk, and indeed it would be if applied to an educated mechanic or even an intelligent laborer. With a man of the mentally sluggish type of Schmidt, it is appropriate and not unkind, since it is effective in fixing his attention on the high wages which he wants and away from what, if it were called to his attention, he probably would consider impossibly hard work.
Throughout his writing, Taylor stresses the idea of selecting only workers who are able to work at the very highest level of efficiency. This always meant firing all the other workers. Taylor had no sympathy for these displaced workers.
And indeed it should be understood that the removal of these men from pig iron handling, for which they were unfit, was really a kindness to themselves, because it was the first step towards finding them work for which they were peculiarly fitted.
The result was a drastic reduction in the number of workers employed, and at the same time a rise in output. Workers were given raises, though, as mentioned earlier, these raises usually did not stay in effect. Meanwhile, the size of management grew. There was an office where labor was planned out. When workers came to work in the morning, they were given a set of written instructions as to how exactly to work. Time-study men patrolled the factory floor, timing motions. There was a proliferation of managers, all dedicated to different aspects of labor control. Divorced from the knowledge of the labor process, the worker became less and less skilled. Work was more repetitive, and it was harder to bargain for higher wages when it was so easy for employers to replace the workforce. Taylorism was also fiercely resisted. It produced much shop floor conflict and militant strikes. Taylor consistently left this detail out of his own versions of his successes, claiming that
during the 30 years that we have been engaged in introducing scientific management, there has not been a single strike from those who are working in accordance with its principles.
Such blatant omissions were typical of a man who could not tolerate anything that interfered with his utopian vision of a planned, rational universe. While Taylor's perfect world, a world free of class conflict where worker and capitalist work toward a common goal of perfect efficiency, never came into being, his ideas about the labor process became part of the basic fabric of working life. The planning of motion in work and management's monopoly over the knowledge of work are a basic fact of the way we experience much of modern work. Scientific management is still taught in industrial engineering schools, and its concepts still inform the basic way workplaces are built and the way jobs are structured. While some of management theory has moved on since Taylor, the basic questions he was grappling with are still crucial. As the productive powers of labor increased rapidly over the course of the 20th century, there was much thinking about how production and society were to be organized, and how the worker would be habituated to the demands of capital. As we begin to look at the history of capitalist crisis, it will be important to keep these basic questions in mind.
There, I think that looks nice. Bob, what time is it?
The time?
Well, you looked at it not 2 seconds ago.
I wasn't thinking about the time. I was trying to find the easiest way of setting this table.
With your watch?
Sure, I was making a motion study.
Oh, Bob, not now.
Marge, if you'd study the motions you make when you set the table every day, I'll bet you'll find you're wasting a lot of energy. In fact, I'll bet there are better ways of doing almost everything around here. Now, take the simple job of setting this table. Women do it the hard way.
Oh, Bob, women can't run a house like a factory.
Why not? Think of the effort you'd save. Maybe you wouldn't be so tired at the end of the day.
If you think you can do it better, you try it for just one day. Anyway, never mind the motions just now. The table has to be set. They'll be here any minute.
How's the new job?
I like it. It's okay.
You're gonna have it. I wouldn't trade with him.
Well, you don't realize what motion study can do, Dick. It works out just like, well, like better machines and better methods. Times have changed. It's a lot different than it was in the old days. Now, we're able to produce more and more stuff with less and less effort on the part of the guys who do the work. That's what motion study's for. We find out how the machines and tools and the methods of using them should be changed to make it easier for the operator. So, as I say, it makes your job as a foreman a lot easier.
Well, it sounds good.
It's more than sound. I can prove it. Maybe this will show you what I mean.
Oh, what's that thing? One of those pin boards we've been hearing about?
Uh-huh. The idea is to put all the pins in the board. Now, all the pins are chamfered, see?
Uh-huh.
They fit easy.
I see.
Just fill the board. Try different ways. Put all the pins in the holes and see which is the easiest method. Want to try it?
Sure, why not?
"40 seconds. That's just about average, Dick, for that method.
At least Bobby waited until after dinner to get that board out. He's even trying to get me doing a motion study for my housework. Let's watch them for a while.
Sure. You girls might like to try it later on. I still say a little motion study around the house would help your housework.
Ready with that watch?
Uh-huh.
Let's go.
"34 seconds.
What do you know? The first method took 40, but this one was faster and even easier. Instead of starting at one end, I'll start down here in the middle, so that both hands are working in line.
Good idea.
Ready?
Uh-huh. "23 seconds.
40 for the first method, and it seemed harder. And the time was only 23 on the easiest method. And I did it just by changing the motions.
See, that's just what I've been saying. That's what motion study does, Dick. You find out how to turn out more work with the same effort.